Hi guys, so this will be a multiple video series on how logic circuits work and specifically how sequential logic circuits work. We start off by understanding what logic circuits are. Logic circuits are basically circuits that are formed when you put a bunch of logic gates together. Now there are lots of types of circuits that are standardly defined in the world. Some of these are things like full adders, others are things like half adders, and then you have things like latchers, stuff like the AND/OR latch or the master-slave flip-flop or the JK flip-flop. So, you start going into this whole arena of logic circuits. So we need to understand, okay, where does the boundary lie? Can we sort of segment these kinds of logic circuits into two different types? And the answer to that is yes, we can. Logic circuits can be subdivided into two different branches. The first branch is sequential logic circuits, and the second branch is called combinational logic circuits. Let's start off with the second branch. Combinational logic circuits are circuits that have inputs that affect outputs. Okay, that is not that confusing. Let's look at an AND gate. An AND gate is an example of a combinational logic circuit, or a simple logic gate actually. And this logic gate basically takes in A and B, and the inputs A and B would be what affects the output Q, right? So A and B are the sole inputs that are responsible for the output Q. Nothing else influences Q other than A and B. So this is an example of a circuit that has inputs that are entirely responsible for its outputs, right? There's no other factor that influences the outputs besides the inputs themselves. And the change from input to output is almost instantaneous. Whatever signal is passed through into A and B is passed out straight away into Q. In the case of sequential logic circuits, which is our first branch, you no longer have that instantaneous process. Here you have an AND gate that is sort of fed back into its input, where the output Q is fed back into one of the inputs of the AND gate. So the idea is, whatever inputs pass into the AND gate, guys, it produces an output. No big deal there. But the output passes back in as another input to the AND gate. And what happens is, whatever output that was realized by this AND gate at time t plus 1, that output passes in as an input to the next cycle or the next in the next time interval. If I repeat what I said, in a sequential logic circuit, you no longer have inputs that instantaneously affect outputs. You have inputs that affect outputs, and those outputs affect the next set of inputs. So the output at the current time interval affects the next input at the next time interval. So Qt is what is taken in as Qt plus 1 in the next interval. So the idea is, combinational logic has inputs that immediately affect outputs, and those are the sole responsibility. The inputs have sole responsibility over the outputs. Sequential logic, on the other hand, current outputs affect the next input, which means that there is this sort of feedback loop where the outputs affect the inputs once again. And that is the introduction to what logic circuits are and their sort of categories, being sequential and combinational. In the next video, let's talk in detail about sequential logic circuits, specifically SR latchers and JK flip-flops.